Alright, we're live. Hello everyone and welcome to yet another recreational programming session. So let's make a little bit of an announcement as usual and officially start the stream. So it's gonna be a red circle live on Twitch, right? And what are we doing today? We are implementing a ripple effect using Opengl shaders. That's right. I've never done that before, so it's probably going to go really horrible. But I wanted to try that for quite some time already, and I recently stumbled upon a very simple article that actually explains it really well. Right, it's just like a single formula, and I just wanted to apply that formula and play with it on the stream. So that's effectively what we're doing today. So yeah. That's basically the topic of today's stream. So the article that I'm talking about is this one. So I just like accidentally stumbled upon it, and I thought that would be a kind of cool topic for today's stream. Right, so I just like look at it and like saw how simple it is, and thought I'm gonna just start the stream. So this is going to be an exploration, just a chill exploration stream. So, and effectively, if you want to have like some sort of a ripple effect on in like using OpenGL shaders on maybe WebGL shaders, WebGL is basically OpenGL anyway. It's just like a bindings, like web bindings to OpenGL. You just have to evaluate some so-called sombrero function, which looks like sombrero, I suppose. Yeah, there we go. So you're evaluating this sombrero function using the heights of this function to offset a texture to which you're applying the effect, and you're gonna get the effect. So yeah, and I'm gonna be using my usual OpenGL template that I usually like develop on the streams. So you can find it in here. So I think I'm gonna copy paste this article in the chat for anyone who's watching right now. All right, so and maybe I'm going to actually do something like you know, I need to update my project. All right, so update CMD project or one sender. So I'm just gonna update the command. So let me see. So here is the project. So I'm making a ripple effect using OpenGL shaders, and I'm gonna also attach this article in here. So that's basically how I'm gonna be operating today. And for anyone who's watching on YouTube, you can find that in the description. And regarding the OpenGL template, you can find the OpenGL template in here, and I'm gonna also put it in the description as well. OpenGL template. All right, so yeah, so it's kind of convoluted template. I created it for myself. Keep that in mind if you decide for whatever reason to reuse it. I don't think this template is reusable by anyone except me because I created it for myself, but so I decided to share it anyway because why not? There's no secrets in there. So, but just bear in mind that I did not put any sort of reusability into that template for anyone else except myself, right? So just keep that in mind. If you decide to use it, I believe that everyone should create their own OpenGL template for their needs, for their like style of development. I don't think there is like a single one size fits all, except maybe in that case, if you come up with OpenGL template that like one size fits all, you basically call it an engine. Right. An engine is essentially an OpenGL template, actually a GPU API template that tries to fit as many use cases as possible, right? So, but this is not what we're doing today. We have like very specific use cases, and that's why I just like keep it very simple, very small, and pretty much only for myself. Okay. So I think I made some changes to the OpenGL template. So let me quickly find it. On my machine, it should be located somewhere here. So OpenGL template, there we go. Do we have any changes in here? I think I have a separate branch for frame buffers and stuff like that. So on one of the streams, I'm developing like a post-processing, essentially rendering the whole scene into a texture and then re-rendering that texture again so I can apply specific effects on that texture, which could be useful today, by the way. We might as well actually apply ripple effect, not just like to a single thing, but to an entire screen. Like imagine a scene with moving object and on top of that a ripple effect. That would be actually kind of cool to explore. So anyway, so did I fetch everything? I think I already did. So I should have just like merged. Yeah, so let's actually merge origin master. So there's a couple of things in here. There's a lot of things in here. So yeah, haven't updated it in a while, but anyway. So let's remove all of these branches in here that are not needed anymore. And there's also this remote branch. I think I also want to remove it if it exists remotely. I didn't know if it still exists there, but yeah, anyway. I fetched with prune, so that means if the branch was deleted, the fetch would delete it as well locally, but it didn't, so that means it still exists. All right, so let's try to rebuild everything. So this is going to be build POSIX. Okay, so the template is rebuilding, hopefully. Okay, and then we can try to run the template. So this is how the template looks like. It just like loads a texture from the file and just applies some sort of effects and whatnot. There's nothing special. It's just a template, so I can grab it and start working with OpenGL without like re-implementing shit ton of like you know, boilerplate you know, every time. So I'm gonna put it in a corner so it doesn't, you know, doesn't bother anyone. And we can start like changing things. For instance, we can try to change the texture that we're using right now. So let's see what kind of textures do we have. We have sleeping texture. I don't think a specific texture matters per se, right? So I'm gonna just keep the regular texture in here. So yeah. Hello everyone, how are you guys doing? So Yesu. Okay, so let me see. Essentially what you have to do, you have to evaluate this function, which is basically some Bayer function. It's a sine of x over x, but you have to do that in 2D. Right, so below is a graph of a sine function followed by a sinc function. Right, so let's take a look. So here is the sinc function, some Bayer function. So extending this to 2D, we have r. I suppose this is sort of like a radius, so of x and y, and z, if we consider z sort of like a height, is essentially... Oh, okay. Oh, I see what's going on. So yeah, to extend it to 2D, we basically take 2D coordinates and we use it as a radius from a center where this entire thing happens. Okay. That's actually very cool. Okay, so that makes sense, as you can see. So R and then Z is just that. And then when you plot it, you have this sort of like a pulse. To turn it into a ripple-like looking effect, we just need to scale down the height of the function and animate it by adding time into the scene, into the sine term to generate repeating pulses. And we have like a simple shader in here, which is super nice. Alright, so what we do here, we take the coordinates of the pixel, of the texture that we're currently sort of rendering, and then we divide it by resolution, and essentially that maps the x and y coordinates of the texture from the screen coordinates, I suppose 1920 to 1080 to just -1, 1, -1, 1, right? So basically you have coordinates for -1 and 1, -1 and 1. Okay, and then we get the length of this sort of vector, essentially. So maybe I can even draw that. Just a second. Maybe I just like need to draw all of that. I'm doing that for the first time, by the way, so I literally stumbled upon this article and I decided that I'm not gonna go any further. I'm just gonna stream how I look into that. So just my first impression. Also, I'm not a computer graphics person, like I'm only learning, right? So this stuff is kind of new for me, right? I know that there's like people, like game engine people out there who's looking at my streams and thinking that I'm an idiot, which is true actually, but it's just like, you know, all of that is for the first time for me. All of that is the first time for me. Okay. So essentially we have coordinates that start from here. So this is 0, suppose x and y. And this is like probably is going to be full HD, right? To some extent. 1080. Right, and then what we're doing, we're just translating all of that into, I think, these coordinates, right? So this coordinate system, because it's easier to apply mathematical function to that specific coordinate system. So this is going to be 1, and this is going to be -1, this is going to be 1, and this is going to be -1. All right. So after that, right, we node a particular point and we take the length of that point, right, in these specific coordinates, and this is going to be our R. Right, so this is C length. And after that, I suppose we're essentially just using it like, yeah. So we put it into cosine this time, right, and also offset it with the time, right? We also offset it with the time, and we multiply it by the position divided by length, which I do not fully understand why we would do that, but okay. Right. So the cosine will give us value from -1 to 1, right? It will give us value from -1 to 1, and maybe this is not what we want, maybe it's too much. So we kind of like scale it down a little bit. So this is the actual position. I suppose this is normalization. Yeah, this is normalization. So this is sort of like a normalized vector. Oh, I see. Oh, I see. I see, I see, I see. Right, so this is the height of the function, right? So this is the height of these specific functions somewhere here. And then we take a normal vector in that direction of size 1, and we multiply it by that height, making some sort of an offset. And we apply that offset to the texture coordinate, right? To the texture coordinate. And then we're just getting that texture and we use the color of this entire thing, if that makes any sense. Does that make any sense? Does anyone have any questions about what we're doing right now? Is everything fine? Because everyone seems to be dead right now. I'm not really sure why. Is that because it's like a boring shit for nerds? So I guess that's true, but that's the stream for you. Anyway, so let's go ahead and just maybe look at some stuff. So do I want to create like a separate shader for this entire thing? So there is a shader that applies sort of just this rainbowish effect. Maybe I want to kind of like replace it with a ripple. All right, so it's going to be a ripple frag. Here's the ripple frag, and I'm going to go into the render and use the ripple effect in here. Right, so this is the ripple effect, and I'm going to just refresh everything, so everything seems to be fine, and I'm going to go into the ripple. Right. Okay, so let me maybe copy paste this entire thing. I don't really want to copy paste it, but I can copy paste it in a separate branch, not branch but window, right? So it's going to be GLSL mode, and we're going to put it like this. So we've got a sub, Azura Akumore. Thank you so much for 4 months of Twitch Prime subscription. Thank you, and welcome back to our epic OpenGL club. How about that? Thank you. All right, so let me see. So right now, if I just remove this rainbowish effect, right? So as you can see, there is just like a regular texture without any rainbowish effect. The next thing I need to do, I need to take the frag coordinates, right, x, y, and then resolution, and that will give me the sort of UV coordinates. And I don't think I need this stuff, if you know what I mean. Right, because I already have UV coordinates, right? I can just like directly use UV. But what's interesting about that is that I still will need to convert them to the -1 to normalized device coordinates, right? So it's going to be something like this, right? And we're going to call this cpos, right? So we're going to follow the conventions established in that file. Okay, everything's fine. In which language? This is GLSL. So I also use C. I don't know. It's just like, is the language really important? Apparently, language is really important for people. I'm gonna put C in the title. Okay, I don't know why language is so freaking important for people, but like you can do that in any language, right? There's so many bindings in OpenGL, it's like the language is not the point. Anyway, whatever. So here is the cpose, and then we need to compute the length of that vector, right? So this is going to be clength, right? Length cpose, right? So everything's fine. And what we're doing in here, so this is another UV coordinates. Maybe I'm gonna just try to do this thing directly, right? I'm gonna try to do it directly. This is gonna be UV, right? This is UV, and I'm gonna add cosine of C length. Right. So you see, they defined a lot of you know, special coefficients in here, right? But I suppose they like tweak them manually, right? I want to just like do like a very dumb thing where I just like apply this stuff and see how bad the entire effect looks like. Maybe it's gonna look horrible, maybe not. I don't know. So, and maybe we'll have to apply these coefficients in there. So I just want to understand the purpose of these coefficients. I hope I pronounced them correctly. I'm not sure if I do. Alright, so let me put this stuff in here, and let's see how horrible it's gonna look like. That's very interesting, actually. That is very, very interesting. So I suppose we'll still have to multiply it by some sort of normalized vector. So it's like, yeah, it looks really funny, actually. It looks really funny, but yeah. I'm thinking, do I just want to go ahead and do cpose, C length, right, and just like multiply it by that, and that should probably give me, and it didn't give me anything at all, and but it compiled actually successfully. That's what's interesting about that. So I'm not sure what's up with UV coordinates. What's up with UV coordinates? Do I want to do UV coordinates like this, or because I pass my own UV coordinates? That's the thing. I pass my own one, and I don't really want to recalculate those things yet again. But I can try to do that. Why not? So GL frag coordinate xy divided by resolution xy. Do you even have a resolution? Yes, I do. Alright, so, and in here, I'll have to do it like that. Alright, so let me try to do that. No, it's still like that. It is, in fact, still like that. And I can try to maybe start, like, subtracting time, just to see how it's... Oh, I see. That is so fucking cool. So it's just like, it didn't... Okay. It's not like necessarily like a ripple effect, alright? It's just like, but it's kind of ripple-ish, kinda, right? Okay, so that's pretty cool. So, and I suppose to like make it look all right, you need all of these coordinates. And by the way, since I know what was the problem, can I just like go ahead and replace this UV with my own UVs? Apparently I can. Okay, so I can just like use the regular UVs in here, so it doesn't really change that much. Cool. So now I'm gonna multiply by these coefficients that they suggest to use. I'm not really sure if they're super important, but they will change something. Okay, so they are in fact changing something, and then we're gonna just shrink this stuff a little bit, and there we go. We have a ripple effect. That is very fucking cool. So I want to like actually put this thing upside down a little bit, right? So vec2 text UV, right? So this is basically text UV, and then I'm gonna do vec2 text UVX text UV UVY. So -1, so it's just gonna be upside down. There we go. So. This is very cool. I really like that. Look at that. Yeah, I suppose you can actually do like all sorts of kind of different warps by just like offsetting the yeah, but by basically offsetting the pixels of the texture by a height of a certain function. By height of a certain function. And in this case, we're just like applying the sombrero function, right? So this is the sombrero function. Right, and the higher the function in a particular point, the like more we offset, right, the more we offset from the center, right, and that what creates this sort of like effect. I wonder what other interesting functions we can try to apply. Right, what kind of interesting other functions? So as far as I know, we can like just take a look at the Wikipedia and just see. Right. I wonder if I can actually move my stuff in here. Right, so I'm gonna move all of that stuff in here. Right. Well, it kind of worked, right? Because I want to be able to just keep that in, you know, in a view, and then just like go around in here. So just a second. So here is a sombrero function, right? So sombrero function. Is there anything, any other interesting functions that we can have? Sync, sync function. It would be nice to like have like a catalog of different 2D functions that we can apply. Though, interestingly enough, is this really... Oh, this is not a normalized function. They make it look like we're normalizing this vector. In fact, we're not normalizing this vector. We're just like applying the function cosine of c length divided by c length. So that's basically what we're doing in here. Okay, that is totally fine. Okay, so we are applying this sort of effect only on the main scene, on a quad in the main scene. In fact, in this particular template, we have two sort of stage, like two phases of rendering. First, we render the scene with all of the polygons. Right now, there's only two triangles in here, right, with all of the polygons. We render all of that into the texture. And then we are rendering that texture again on a bigger quad. And we do that so we can apply more different effects in the post-processing of the scene. Right, so right now this is not done in the post-processing. I would like to have like a lot of like different objects moving around and then globally apply this rippling effect there. I think that will be interesting. I think that will be interesting. So let's actually go ahead and try to do that. First, we need to actually see that we have you know, something on the scene. So let me make this entire thing a little bit smaller. I'm gonna go into the main function and I need to find the quad that we're applying here. So here's the quad, and we always apply the quad of the entire size of the screen, which is probably not what we want to do. So let me apply the quad at the position of the mouse, right? So this is going to be something like that. So X position and Y position, right? And then we're going to do something like this. So let's say that the size of the quad is going to be 100. Unfortunately, I will have to restart the whole application because I can't auto reload the C code, and that didn't really work, surprisingly, at all. So that is kind of sus, not gonna lie. So why it didn't work? This is because I didn't actually rebuild anything, right? So this is going to be build POSIX, and let's restart the entire thing. And as you can see, this entire thing is actually way smaller, and it's actually following my cursor. So it is in fact following my cursor. That's actually interesting. So that actually kind of confirms that the entire effect is not applied like globally to the entire scene. So maybe it would be nice to, I don't know, make this thing follow, but not like being attached to the mouse. So essentially like follow slowly. Right, follow slowly. So this is going to be something like that. So we're going to have a position of the texture. So this is the position of the texture, and that's what we're going to use in here. So this is going to be x and y, and we're going to have like a velocity of the texture, right? So this is going to be something like this. So position and the velocity of the texture. On each step, so this is where we compute everything. On each step, I'm going to be essentially applying the velocity of this entire thing multiplied by delta time. Right, so multiplied by delta time. This one is just x and y. All right, and then I think I will have to constantly recalculate the velocity depending on the distance of the current position from the mouse or something like that. Right, so this is what we can do. X position minus x, right? So, and let's say that this is going to be the velocity. So it would be also nice to maybe multiply it by some sort of a factor at some point, but it can be done later. Okay. All right. So as you can see, it is following the mouse, right? So, and it's funny how like the further away it is, the faster it is following. So I think that's pretty cool. We can make it actually follow, you know, a bit faster, so twice as much. Right, so it can follow twice as much. So, it's actually pretty cool. We can probably make it some sort of like a constant, right? So basically, follow scale, right? Some sort of follow scale, and maybe we can put it into the configuration file. That would be actually kind of interesting. Can we put that in a configuration file? I think we should be able to. So in a configuration file, like render.conf, we have like different configuration variables like shaders, like vertex and fragment shaders, the texture that we're currently using, and we might as well just like introduce the follow scale, right? So how quickly you're following. So in here we're gonna just have 2, or maybe something else. Reload render conf, right? So we are reloading render conf, and somewhere here we can just do something like if we encountered something like sv equal key, like follow scale, right? If we encounter that, we're probably going to use something like str2f, right? Is that a function that we can have, str2f? Right, so here is the function. So, and I'll have to provide the value data, and here I can just put null, it doesn't really matter. Follow scale, right? So this is the follow scale. And then I can put like a follow scale somewhere here. Float follow scale, and it's going to be essentially initially like 0. And here maybe I'm going to also make it static. Right, so it's going to be I. And there we go. So every time I want to change that that scale, I won't have to essentially reload the entire application. I'll only have to like change the configuration file. So it says that it's unused, which is rather strange. Yeah, because I'm an idiot. I see. So that's pretty cool. Let me maybe experiment with this entire thing. So I'm going to make it a little bit bigger. So, and I'm going to go to the render. Right, and in here I can just change it to 0.5, and now this thing is going to be following it very, very slowly. As you can see, it is following very, very slowly, but at any point I can say, okay, so the coefficient is going to be 5, so it's going to follow it super, super fast. So as you can see, I can now adjust this parameter like just like that. Should be relatively easy. So I think 5 is all right, maybe, right? Maybe it is all right. It would be kind of nice to have more objects in here, like as I apply more effects, if you know what I mean. right? So maybe we're going to have a second object that follows this first object. But we don't want to like follow it the same way as it follows the mouse, because they basically going to snap to the same exact position. So maybe they're going to try to stay like a certain distance from each other, right? So if there's a second object somewhere in a different place, it's going to follow that first object, but only up until it you know, reaches a certain like distance towards that object, if that makes any sense. Right, so we can try to do something like that. Does it make sense? Alrighty, so we've got some subs. I'm really sorry that I missed them. Ampersands are cool. Thank you so much for tier 1 subscription, your first subscription, by the way, and welcome to our epic OpenGL club. About that? That's right, we're doing OpenGL on this channel. Did you know that? Did you freaking know that? Also, maybe I would like to have the size of the objects also in the configuration file. I accidentally closed the chat, by the way, which is probably a good thing, but not right now. Right, so, okay, so let's say something like object size, right? So, and right now the object size is 100. Right, so if I find 100, I can say something like object size follow scale static float object size 100, and somewhere here we're going to have object size the same way. There we go, should be fine. Okay. So, and now I can just experiment with the object size. There we go, so it could be small, it could be even smaller, right? So it could be something like that, so this is a very small object, or it could be super big, like 1,000 of those things, and it's going to be like right into your face. Right, so let's take a look. So this is how big it is right now, right? And all of that is like now controllable in here, which is fine. So I think around 50 was a pretty good size for this object. If it's so small, I would like to also like move a little bit faster, like around 7, right? So I think it looks actually very nice. I think it looks pretty nice. So all of those things are now configurable. We can play with them. But maybe for now, while I'm like, you know, doing some other stuff, I'm gonna just do something like this, right? So let's just let it sit in here while I'm doing the other thing. So we're starting to have more objects. How can we add the second object, right? The second object that is like keeps moving, all right, so this is x, y, and dx, dy. So maybe it makes sense to actually abstract out these 4 floats into some sort of a structure and call it an object of some sort, but I don't know how we're gonna call that. We can call it just a face, because this is basically a face, right? The face that is just like keep following you. Right, so let me see. So this is going to be type def struct face. This is the face, and float x, y, dx, dy. And what other things we need to have in here? I suppose we need to be able to render that face on the screen. So we need to have something like face render, and it will accept the current like renderer with which we're rendering things, and the pointer to the face. Right. And it should be as simple as pushing the quad. So I forgot how to, yeah, there we go. So in here, we'll just do face X, face Y. So we also pass the color, but I don't think if it matters that much. Right. Though I don't like the name face. Let's actually call it object. Right, object render. Object. Right. X and Y. So, and another thing we need to be able to do, we need to be able to update it each frame, right, with the delta time. So it's going to be object update. object float delta time. So, and in here, I'm gonna just move the this thing, right? Though I'm not sure if that's how I'm gonna do that. I'm really not sure. So I think for now, I'm gonna just move that stuff in here, like, you know, delta time, moving the delta time. There we go. Now, in here, we're gonna have like a main object. So this is object and this is main object. And in here, I'm gonna just zero initialize everything. So it starts at 0. Then I'm just doing object render. I provide the renderer and main object that is following the cursor. And then in here, oh boy, where is my so I'll have to do something like object update. So this is a main object, and I have to provide the delta time. Right. So, but in here, I'm basically computing the new velocity for the object that I'm following. So I think maybe object update should also accept the target X and target Y. So then it would make it easier to chain the second object into the equation, if that makes any sense. Right. So that's probably what we should try to do. So I'm gonna go to object update and accept target X and target Y. Right. Float target Y. And in here, I'm going to just grab the entire thing, right? Move it in here. And instead of X and Y, we're gonna have target X, right? So this is gonna be target X follow scale. So it should be probably called follow speed, but doesn't matter. So in here, I'll also have to prefix all of this stuff with like object. You know what? I think I want to call it obj, so I don't type too much, right? So I think object is like literally too much to type. Object that, then another thing here is object that, and this is another thing, which is object that. There we go. Can I recompile the entire stuff? Is it recompilable? So, okay, let's take a look at the compilation errors. So, like, I literally renamed it to object. I'm sorry. I think I'm an idiot. So, all right. So, and the follow here is going to be X pose and Y pose. Right, X pose and Y pose, and everything seems to be okay. All right, that's fine. Cool, 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 cool. So now we need to have the secondary object, right? So second object, which is also going to be like this. Second object, and I want to render this second object like this. So this is the main one, this is the second one, and in here we are effectively updating the second object, the delta time, but we're following the main object, right? We're following the main object. But to follow the main object, we don't really want to follow the exact position of the main object. If we try to do something like that, so X, they're just basically gonna snap together. In fact, they already stay in the same position, so it is kind of, well, there will be some sort of delay, I think, between them. I think there will be some sort of a delay between them, right? So let's actually see, let's actually confirm. But at some point they're gonna like snap into the same position, yeah. Yeah, okay. Huh, that's pretty cool. Look at that. Look at them go. Yeah. It's pretty cool. So, and we can probably just like change the size of these things. Like I originally wanted them to be 50, right? So now, yeah, that's pretty cool. So maybe it's fine, right? So since there's still delay between them, you see, there's still delay between them, and that's kind of fine, right? That is kind of fine that there is a still delay between them. So we can try to add the third object, right? We can try to add the third object. So this is going to be the third object, and here is the third one. And then we're going to be chaining the third object into the second one, right? So third object, and this one is going to be the second one, right? And there we go. So let me see, is it going to recompile? So there's 3 of them. So we want to actually have like arbitrary amount of objects in here. So I want to have some sort of like n that controls the amount of objects and actually chain them automatically, if that makes any sense. Right. So let's actually make them maybe a little bit bigger. Yeah, so they are a little bit bigger now. Cool. That looks so cool. I really like that. Look at them go. Ooh, Poug. Okay, so let me see. I wonder what we can do in here. We can actually make it follow not the mouse for now, but some sort of like a procedurally generated point. Right, so let's actually make it follow something like sine of time, sine of the current time, and the cosine of the current time. But the coordinates are screen coordinates, so it's going to be kind of lame, if you know what I mean. So I can multiply that by some sort of a radius. Right, radius. Radius, and the radius in fact is going to be something maybe 100, right? So, and it's probably going to follow in the bottom left corner, right? But we want to do that in the center, so that means we'll have to do a little bit of a translation for that one, right? Oh no, they're already in the center. That's actually POG. That is actually super POG. So I'm going to increase the radius to like 500, and I'm also going to increase the speed. Right, so let's call it something like speed, I think, right, float speed, and maybe it's going to be around something like this, right? Yeah, so now they're just like, like without me, so they're just like moving around. I'm not touching anything, they're just like rotating. Hypnotizing you, basically hypnotizing you. And what's fun is that we can now move these things into the configuration as well, right? So we can call it like rotate radius and rotate speed. Right, so this is going to be a rotate speed and rotate radius, and I'm gonna move that to the configuration in here, a runtime configuration. Right, might as well just like take the entire thing. Rotate radius, and now float follow scale. This one is going to be static float. So rotate radius, and it should be super easy to just add all of this stuff in here so we can control it. Rotate radius, and now rotate speed. Right, this is rotate speed. Okay, so that means I can put this stuff in here, and for example, now I can just see radius. Let's actually cut it in half, right? So I cut it in half, now it looks like this. What's interesting is it kind of goes to the new radius slowly. Right, if I change it back to 1000, it's not gonna jump anywhere, right? It's just like slowly goes back. That's so cool, right? Oh shit, that is so fucking cool, I like that. Oh my god. So, wait a second. Can I do something like that? Right, so this is gonna be 5000, alright, and I might as well call that shit. 1000. And then around like 10. Yeah. So cool. We can maybe make it a little bit slower. But it could be around 10, I suppose. Right. So with such a radius, it's actually like not clear what exactly we're doing in here. Right. Maybe 5. And of course, we can reduce the object size. Yeah, so they're smaller. They're a little bit smaller now. 75. Yeah. So that's pretty pogue. That's pretty pogue. So that's a pretty cool system, right? So you can just like dynamically reload all these things. So let me put this stuff somewhere here. Right, let's just keep it in here. While I'm working on the rest of the stuff, because what I want to do right now, I want to actually have several, like basically variable amount of such objects, right? Variable amount of such objects. So maybe follow scale is going to be like 5. And rotation speed maybe 2. So I don't want it to be like super annoying. Follow scale maybe like, yes. Oh yeah. Look at that. That is way better now. So I'm gonna just keep it like that. What an absurd program. It's not a program. Well, I mean, it's programmed by some definition. So all right. Calling this a program is the same as calling a sketch a painting. All right, let me now have an array of those things. Right, so obviously we want to have an array of objects. So let's define something like objects capacity, and how many of them do we want to have? Let's say we're going to just pre-allocate like 1,000 of objects. So we're going to have an object, and here is objects camp. And how many of them do I want to have in here? So I'm going to say objects as z. Initially it's going to be 0, but what we can do, we can probably bind the amount of objects to the configuration, right? You know what I mean? Right. So then I can change that from the configuration, which is actually kind of cool. Right, so that means I'll have to put that somewhere where we reload the configuration. So this is going to be follow scale. So this is the render config. Let me put it somewhere here. So that means that the definition of the object also has to be somewhere there, right? Which is fine, I guess. This is C. Follow scale. I should probably put it up there. So follow scale. So how should I call that? Object count, maybe? Objects count. So that's what we're gonna have. And in here, if I encounter something like this, this is gonna be objects count. Objects count. And instead of str to f, we have to use str to, I don't even know, how is that called? Str to d, not I, str to I. I think it's signed. Str to u, I think that's what I was thinking about. This is the thing I was thinking about, str to u, and convert string to u and max. Ah, LD, I think that's what it's called. The standard one is called str2ld. Right. That's the standard one. Supposed to be. No, LD. Man, str2l. Yeah. 2ll maybe. Yes, that's what I wanted. I think that's what I wanted. I'm pretty sure. No, I'm gonna do what? str, so this is equal, and in here I'm gonna take the value data, the end pointer I don't care about this, so I'm gonna put null in here, and for the base, obviously we're gonna use 10, right? Obviously we're gonna use 10. Another interesting thing is that we need to check if it didn't overflow. So essentially I can check if objects count is greater than objects capacity, right? So I think I will have to cap it to the object capacity. So I think that's the easiest thing to do in here. Right. And we might as well even print something on the screen, right? So SDLD. So this is the position within this within the configuration. Warning: objects count overflow, right? Objects count overflow, and the position of this thing is somewhere here. So we're just doing that so we cannot accidentally set a huge value and buffer overflow, right? We don't want a buffer overflow, especially in C code, right? Am I right, RISE developers? Am I right, RISE developers? You don't want a buffer overflow. Okay, so object size, we don't have an object size. So that means I'll have to define all of that before the configuration in here. All right, so I'll have to do it like that. And all right, so we have 3 of them. Okay, that's fine. This is because I didn't even, you know, wrote the code that actually chains all of these things together. So let me go to the render config, and let's say that objects count is going to be, for now, 3. So we literally have 3 object counts. All right, so this is 3 and this is fine. Okay, now when I'm rendering all of the objects, we're not going to have even like main, second, third, like it doesn't matter, right? We have several objects now. So size t, I less than objects count, right? Plus I, and we're rendering each an individual object in here. So render r objects I, right? So that's what we're doing in here. So I'm rendering all of the available objects in here. And then when I'm chaining things together, I need to probably use the zeros object as the main object and then chain together the rest of the stuff. So, but I can't do that if I don't have enough objects. So I will probably have to check for something like objects count has to be greater than 0. So we're going to be updating the objects only when they're greater than 0. Right. So, and now what I'm going to do, I'm going to do update objects 0, right? Delta time, and I'm gonna be using this follow point, right? So this is basically follow point, and I'm gonna just like put it in here, right? So after that, I need to start iterating through the rest of the objects we have, right? So it's gonna be size I, probably starting from 1 because we already updated the object 0, right? So we already updated the object 0, and we need to, you know, work on the rest of them. So this one is going to be objects count plus I, and all right. So this one is going to be essentially object 1, object I. We're updating object I, and we're making it follow the object I-1 position, right? So the next object follows the position of the previous one, right? So hopefully that will work. So this is just object. This is several of them, right? This is just several of them, and we're gonna have several. Okay, so we have 3 of them. So now I can go ahead and put 4 in here, and we have 4 of them. We literally have 4 of them. It's kind of difficult to see them, so I think we need to increase the radius. So let's actually do 500. So now we have a little bit of a radius. So as you can see, they're doing this little dance. Maybe they should follow each other a little bit faster, right? So now they're following each other a little bit faster. What about adding the 5th object? So here is the 5th object. So now we can add up to, I suppose, 1000. We can try to add 100, and that's a lot of objects in here. That's 100 objects, and they're swirling around. So 100 objects. So we can make them just follow a tiny bit faster, so they like detach from each other like a little bit, so they unswirl, if that makes any sense. But yeah, at any point I can just say, okay, let's have 10 of them. So let's cut out the rest of them. So this is going to be like 5. Right, around like 5 should be fine. And yeah, there we go. Though, if we're gonna have a round of 100 of them, right, so this is 100 of them, it would make sense to make them a little bit smaller. Right, so yeah, if we're gonna have a lot of them, it makes sense to make them a little bit smaller. Right, so, but that is only if we're following this, like, procedurally generated thing. What if we bind it back into a mouse? Right, so we can try to do that. I'm gonna just close this entire thing. So here, I suppose it makes sense to maybe extract all of that thing to something like float follow x. So we're following this thing. Though I'm not even sure why I'm using sine for x. I think historically x is cosine, isn't it? I think it is. I think I confused them a little bit. But that's fine. I'm not a mathematician. That's totally fine. It works out anyway. It works out anyway. Follow y. Right, okay. So, and in here I just can comment it out and then use expose and xy. So that way, this entire like sort of fiesta is going to be following my mouse. Hopefully. Right, there we go. Look at that. They're following my mouse. So they should be actually, I think, following a little bit faster. So let's make it like 10. So, yeah, 100 is too much. So let's do 10. So yeah, that's pretty cool. Though we can make it even cooler. What if we don't make it follow just the mouse, but make it follow point that is rotating around our mouse? So we made it rotate around the center, but what if we made it rotate around the mouse a little bit? Right, and we can use the same radius as before, so we can combine both of these things. So this one is going to be just essentially, you know, something like this. Okay, so this is going to be plus, and I can just like do it like that. Let's restart the entire thing, and let me see. So it is rotating around the mouse, but the radius is too huge. Like it's rotating around a very huge radius. So let's go back into the configuration and say that the radius is going to be 100. Right, so, and they're following the mouse, but they're rotating around the mouse. Right, so... it's pretty cool. I really like that. Alright, so and rotation speed, we can also speed up the rotation speed, right? So they can rotate a bit faster. Right, and we can have like more of them, 20. So here are the rest of the objects. Okay, this is so fun. Like I don't know why, but isn't it fun? That's the joy of programming, by the way. That's literally recreational programming. People ask me all the time, Zoljan, why are you doing this? Why are you doing that? What's the benefit? Are you gonna make money out of that? Like, isn't that just fun? Isn't just farting around with computers freaking fun? Like, I think people are forgetting how fucking fun it is. It's just like annoying. Seriously. This is fun. This is so fucking fun. Anyway, so I'm sorry. It's a little bit frustrating. So object size, and let's make it like 50 or something. Yeah. So rotation radius, can I just make it like 300? Yeah. Okay, so the reason why I was doing all of that is because I wanted to have like some sort of moving object on a scene, and when I switch the, like, because originally what we created, right, what we originally created, so maybe I should stop like everything that's going on. So I'm making everything super slow, right, so this is going to be around like 1, and then I'm going to make the textures really big. So that's not what I wanted. All right, so I wanted to make the size of the object like around 300 maybe. So as you can see, originally what we did, we applied the ripple effect on the texture, right? That's what we did. But the ripple effect applied to each and individual object. So what I want to do, right, I want to have some sort of like a dynamic scene, and I want to apply a ripple effect in the post-processing on the entire scene. Right, you see, so basically I want to detach that effect from specific objects, and I want to apply that effect to like literally everything. And moving objects are going to help like to have a point of reference to actually see what's going on. Right. So that is going to be interesting. All right. So let me move this stuff away. I really like how it looks like. Okay. So maybe I'm gonna, yeah, the radius is kind of too big, so let's actually make the radius 500, because otherwise it's not really visible what's going on. Oh, this is object size. Right, let's keep object size like that, and the radius has to be, maybe it's fine. Okay, it is fine. Cool. Just a sec. All right. So we have a shader in the post-processing, right? We have a shader in the post-processing, and that shader in the post-processing is responsible for actually creating the flashbang effect when I reload everything. You see? So every time I reload something, it like creates this like flashbang effect. And for instance, if I made some sort of a mistake inside of the shader, for instance, in a ripple frag, right? So in a ripple frag, I forget like semicolon, it will flash with the red. Then I can reload it again and it will flash with green. So this is entirely the purpose of this sort of like a post-processing shader. But I think it's kind of useless, right? I don't think it's that particularly useful. I think I want to repurpose that post-processing shader to actually apply the ripple effect instead. That's what I want to do. Let me see how I can do that. So I'm going to literally go, though I can't hot reload the post-processing shaders, so I'll have to probably restart the whole application, but that's fine. So we have a flash fragment, right? And this is what we're doing here. So T is responsible for the current value of the flash. So that is fine. So where is my ripple? So ripple frag. So what I'm thinking is that I'm going to disable this entire thing, right? I'm going to disable just this entire thing and just apply this stuff like that. So as you can see, there's no ripple effect on individual textures anymore, right? As you can see, there's just no ripple effect. Though there's too many objects. Let's actually make 3 of them or something. Yeah. Cool. And I want to now go back to here, right? So I do have UV coordinates. That's fine. That is totally fine. But I don't have the time in here. Uniform, let's call it float time. And when I'm synchronizing the uniforms for the flash sync uniforms, right? I think I also want to have a uniform responsible for the time. So here is the texture uniform, color uniform, and the T uniform. Let's introduce GL int time uniform, right? Time uniform. T uniform. Okay, so this one is going to be just time uniform. T uniform. This is the only place where we update it, right? So flash sync uniforms. GL uniform 1F. Uniforms is basically global variables that are visible to the shaders, and shaders are programs that you run on your GPU. Right, so just for anyone who just joined and doesn't understand what is OpenGL shaders and stuff like that, right? Shaders are programs that run on your GPU, right? And uniforms are just like global variables that are visible to the shaders, right? So, and basically what I'm trying to do, I'm trying to pass the current time to the shader so it can use that time to animate, to create the animated ripple effect. So that's essentially what's going on. All right, and the next thing we're gonna do is a time uniform, right? So I'm setting time uniform to the current time, and I think the current time is currently like global variable, literally. So yeah, I don't even have to pass it anywhere, so that's fine. Okay, so let me see. Okay, so that's cool. That is very, very interesting. But I'm not sure if it's actually working. I think in the post-processing shader, yeah, okay. So everything seems to be working. If I try to do something like this, it should not compile, it should not start, because yeah, the post-processing shader does not compile as well. It does not compile as well, okay. So that's cool. Now, in the post-processing, I'm just gonna apply text UV. Right, I think it's gonna make everything upside down, essentially. Right. So, and as you can see, the ripple effect applied to the whole scene. Right, so we can actually make more things on a scene. So first of all, let's make the objects a little bit smaller, like 100, and let's make 20 of them. And let's make them move a little bit faster, right? So, yeah, as you can see, now the ripple effect applied to the whole scene. That's actually super cool. Right, so not an individual texture, but the whole scene. Yeah, and this is because we have like a post-processing like pipeline in here. Some sort of a post-processing pipeline. And it's achieved by rendering the whole scene into a texture and then rendering that texture with additional shader, right? So we have two shaders. The first shader that just renders the original face, and the second shader that renders the ripple effect. And what's funny is that we also have, we use a ripple shader in here, but if we use the original shader here, it also applies like a rainbow effect on each individual thing in here. So that's cool. There's so many layers of effect in here. Look at that. This is the beauty of OpenGL, by the way. Right. So if you master it, like I'm by no means actually mastered OpenGL, but once you understand it, you can layer effects upon each other like that. So there is a separate effect of like that is applied on each individual object, and then like a global effect and whatnot, and that's what we have in here. That's so cool. Right, and it follows your mouse as well. Holy shit. So that is so cool. We can use like other textures, by the way, believe it or not. Right, so let's actually put this stuff in here. Right, and I wonder, it kind of does not allow me to properly do all of that. So okay, let me grab a poggers emote. Right, so we're gonna have a poggers emote. I'm gonna put it into the assets. Right, so I'm literally downloading it. Poggers, I suppose it is PNG, right? It is PNG, hopefully. Why does it take so much time to download a goddamn emote? I don't know why. So copy, so that's probably why, because it was downloading maybe some sort of a thing. And if I take a look at the file of this entire stuff, it is a PNG, so this is a poggers PNG. Right, so then I can go into the renderer, and here I can use the poggers PNG. Boom. And it didn't work, surprisingly. Okay. So what's the compilation error? Poggers PNG does not exist. It's a single pogger. Sure. So this is poggers. Isn't that poggers? I think it's pretty fucking poggers. So yeah, that is very, very poggers. That is as poggers as you can get. So maybe we're gonna have like radius like 500. So that is very poggers. Follow scale like around like 10. Ooh. Ooh. All right, so that's pretty cool. What the fuck am I doing with my life anyway? Many poggers, yes, that's as many poggers as you can get. So the radius is going to be 300, let's say. Ooh. And what's funny? You can at any point stop the whole process, I think. Well, you can't do that anymore. Oh shit. I think I broke something. Ah, I know. All right. So our game update code does not care about the pose state. That is very important, by the way. So object update. So essentially, only when we're not in a pose state, right? Because I also have a global pose state. Right, so we have stuff like this, and that stops everything. And then you can actually step through the entire thing. If you have any sort of bugs, right, you can just step through the time, and that allows you to do that. If you want to debug something, right, so you just want to see something in here. So that's very, very cool. You can go back in time as well, though. Again, game code, like when you update the object, doesn't really care about the stepping back, unfortunately, right? So because it's stateful, it is very, very stateful. But the animations that are not stateful, like ripple animation, they're actually fine. So alrighty. You know what would be even cooler? If we had like a single object. And right, when it moves, it would leave the sort of ripples, if that makes any sense. Right, trail of ripples. So we want to have like several ripples then. So how can we have several ripples? I can have 2 ripples, right? Essentially, I can just like have 2 points of the sources of the ripple effect, right? But what if I want to have n of them? I suppose one way to achieve that is to actually have quad that sort of applies the ripple effect on everything that's behind it, right? And basically spawn that quads. And yeah, so that's probably how you would do that essentially. Right. And you would probably create such quads in post-processing. Yeah. It's probably, yeah, you'll probably create them in the post-processing. So in the post-processing, you would have like a quad that renders the whole scene, and then additional quads that render small subscenes with the ripple effect, and you can have like a trail of them, if that makes any sense. Does that make any sense? Probably. So... Yes. And I can also go back into this thing, right? So we're gonna have like a Zozin. Let's actually make them a little bit bigger. That makes very sense. And by the way, just for a record, like I'm doing all of that for the first time. Maybe there is a better way of doing all of that stuff, right? So maybe there is a way better way of doing that. But I've never done anything like that before. So, and that's actually pretty cool. And like, I'm surprised how simple the entire math is, right? You just like apply this sombrero function, right? For anyone who just joined, so this is basically how you do this ripple effect. So it's a very simple article, right? So this is the entire function, and you just like code that function into the fragment shader and you get this. It's just so fucking cool. I love that. I didn't expect that it's gonna be so fucking simple. And maybe you can again reiterate on that idea and just basically have more functions, more different interesting functions that do different interesting things. So yes. Kawaii freaking desu. All right, so maybe I'm gonna make a small break, and after the break, after I made a cup of tea, we're gonna try to maybe create like multiple individual ripples, right? So I think that would be actually kind of cool. So yeah. All right, so what I wanted to have, I wanted to have basically several ripples. Right now, as you can see, we have sort of like a single ripple that starts from the center. But the question is, how can we have several of them, right? And I suppose, as I already said, we need to have like quads that, you know, form, that basically spawn the separate ripple effects there. But it's gonna be kind of difficult to achieve, because essentially what we'll need at least 3 shader programs. The first shader program is the one that renders the objects and like rainbowish things. The second shader program like does post-processing, right? Basically renders the scene that we already rendered into a texture. And then the third shader is going to be applying ripple effects into the post-processing in different places and stuff like that. So this is actually rather complicated. I'm not sure I'll be able to do that within like a single stream. So because it's rather complicated, not gonna lie. And we'll probably need like a separate sort of renderer, so to speak. Right. So let me see. We have all of that stuff in the Flash. All right, so this is gonna be assets. Shader, Flash, frag. Might as well actually just like bring back the program, right? And just keep it in the background for people who just joined to see what exactly we're doing in here. So maybe it's interesting for somebody. Right. So it's gonna be in the background doing its own thing. Maybe though we're gonna try to make it a little bit slower, right? So it's gonna be something like that. Right. Something like that. Though in a Flash, right? Shader Flash, actually Flash frag, right? So here's the frag. I'll have to do something different, right? I'll have to do something different. So for now, I would like to maybe disable this entire thing, but maybe not. So I have an idea. So I already have something called a renderer, right? So, and a renderer contains all of the, you know, vertices on all of the triangles that we're trying to render. What if we create this second one, right? What if we had a second one for specifically ripple effects? That would be kind of interesting. So this, we have a global renderer in here, and here we can have another renderer, right? So this is the second renderer, but that renderer is, oh boy, how can I call that? This is the ripple renderer, right? So we can call it ripple renderer. So this is the second one. We have a global renderer. And where do we initialize it? So we're initializing it in here. And when I initialize the global renderer, I create a new VAO. Right, I create new VAO, I create new objects, and stuff like that. Right. So, which is totally fine. Which is probably something that I might want to do. And then we do reload. Look at that. And when we're reloading the this thing, I suppose we're reloading very specific shaders. Where do we get the... Oh, here it is. So it's a vert path and frag path, and we get those things from the configuration file. Okay, so that makes it a little bit complicated, but that's fine. That's fine. I would rather prefer, like, have them from the parameters, right? So I think it will be way better if they were parameters. So let me do something like float vert path and float frag path. So I might as well, so all of that is going to kill the current program. So I'm going to do the following thing. I'm going to rename this thing to ripple. Alright, and I'm going to just run the REPL in the background like that. Hopefully that's not going to cause any problem, because I'm definitely going to be rebuilding the entire stuff and doing something, and that's going to kill whatever we have in the background, and we don't want to do that. Okay, so here I do load shaders, incompatible. It's not float, what the fuck am I doing? It has to be const char, right? So it has to be const char. Okay, so what is the other thing? And when I'm reloading this entire thing, I also probably want to accept the paths from here too, so that way I can actually customize which a renderer uses which shaders. I think that makes sense. So this is a vert path and this is a frag path. So apparently we got some subs. Just a second. Thank you so much, NerdX. I hope I pronounced your name correctly. Thank you so much for gifting 1 tier sub to Anmignon. I hope I pronounced your nickname correctly as well. Thank you, thank you, thank you. All right, thank you for the support. Okay, so I'm gonna pass it in here, and now it is going to ask me what exactly I want in here. So I'm reloading the global renderer, and here I'm gonna just use vert path and frag path. Vert path and frag path. All right, so when I'm reloading this entire thing, I also want to use vert path and frag path. All right. Okay, so we have a REPL renderer, and I suppose what we want to do, we want to also initialize it. So it's going to be our init REPL renderer, right? So we're initializing REPL renderer, and we're reloading the REPL renderer as well. For the Vertex Shader, we're going to be using the main vertex, right? So I think main, it just contains everything, like, yeah, it's basically the same one, right? It's essentially the same one. And for the fragment, we're going to be using the REPL one, right? We're going to be literally using the REPL one. Main.c. REPL frag. REPL frag. Okay, so let me see if this entire thing compiles. And here is an interesting question. Will this entire thing still work? It still works, surprisingly. Okay, that's very cool. So now I have sort of like two separate renderers. I can try to maybe do something like this. Maybe restart everything like that. So it should complain that there's no such thing in there, and that's fine. Right, that is totally fine. Okay, so this is gonna be the vert. This is gonna be the vert. So here we're rendering the scene into the frame buffer, right? We're rendering the scene into the frame buffer. Then I'm rendering the whole texture, right? The whole preprocessed texture. And on top of that, I suppose now I wanna render the additional thing, right? So I wanna, I suppose, just clean our clear, right? The same way I clear the global shader, I'm gonna be cleaning the REPL shader, REPL renderer. Then I need to synchronize the uniforms. I might as well just like steal the whole thing from here. So, but instead of the global one, I'm going to be using the REPL renderer. And also I'm going to be synchronizing the buffers. All right, I'm synchronizing the buffers. REPL renderer. And then I'm just rendering the whole thing. Okay. So, and between these two things, right, between synchronizing the uniforms and synchronizing buffers, I should be able to simply put some things in there, right? to put the quads, and those quads are supposed to use the texture of the scene to produce the effect. That is very interesting. So I don't know how to explain that. So I can try to draw that, right? So let's actually try to draw that. Maybe it's going to make a little bit more sense. So we have the screen, right? So, and we're rendering the scene, right? And the scene consists of the several squares in here, right? So we have them like this. So we're not rendering that scene into the screen. We're rendering it into the texture. So this entire screen is within the texture. Then we're taking that texture and only then rendering this entire texture. And this is needed so I can post-process the entire scene and have like a global ripple effect. So that's how I achieve this global ripple effect through post-processing. So if I want to have localized ripple effects, I'll have to, in the post-processing phase, use quads that use the texture of the scene to sort of like localize it in here and warp specific sub-region of that scene. So that's how I have to achieve that. Right, first I need to render the scene into a texture, then render the texture itself, and then on top of that texture I have to put the quads that use subtexture and warp that specific subtexture to create like localized effects of warpness. Does that make any sense? Right, so there's like 3 steps in here. Draw the scene, then put the texture, and then on top of that texture like puts the warp effect. Alrighty, so that's pretty pogue. I will never be able to do that. Okay, so I want to put some sort of a... Yeah, let's just put a single quad in there. This one is going to be R quad CR, R quad CR. CR stands for center radius, right? So, and I'm going to probably just use the position 0, 0, right? So this is the position 0, 0. And we're going to use the object size. So the localized warp effect is going to have the size of the object. So now let me maybe try to do the following thing. When I reload everything, so when I press F5, right? When I press F5, I'm reloading the configuration. Right, and then I'm reloading the config itself, right? So here I'm reloading the config itself. And another thing I probably have to do here is this. So I'm reloading this one, and then I also want to reload the ripple one, right? I want to reload the ripple one. Ripple renderer, and in here we're going to be using what? Yeah, so that's the stuff. Cool. So we're reloading the global renderer, then we are reloading the ripple renderer, and that should be it. Okay, so another thing I want to do in the Flash stuff, I want to completely disable the ripple effect. I'm going to be disabling the ripple effect. Right, because now it's not going to be there. It's going to be on a different level completely. So, and let me take that stuff and just, oh, there we go. So, let's fix all the compilation errors, and what do we have in here? Okay, that's cool. We don't have a ripple effect anymore, but we don't have anything localized either, which is rather interesting. Right, the question is why? Why don't we have anything localized? Probably because we'll have to, when we synchronize the uniforms of a particular renderer, right, we do not take into account the texture of that specific renderer. Actually texture unit. Right, so actually texture unit. So in the shaders like main frag, we just have a tag, right? We just have a tag. So, but we never actually explicitly set it anywhere. So I think I need to go to the uniforms and do something like tag uniform for the renderer. Right. Okay, so this, let me take a look at this thing. This is going to be for tech, tech. All right. And another one is for, and when I'm updating this thing, it's a tech uniform. And here we have a tech unit. I think this is how I'm going to call it. So gluint tech, right? Like a latex in tech. So this one is going to be 1F. Okay, so, and when I'm doing that, so for that one, I think for the main renderer, the unit is going to be 0, right? So that's the unit. And for the second one, the unit is going to be actually 1, right? The unit is actually 1. And did it create the... okay, so there is some stuff in here. Okay, that's fine. That's actually good that we have something. Failed to read main vert, no such... Okay, so I see what's going on. So it's throwing errors and shit. So this one is supposed to be shaders. Shaders, and let me find the second main vert. And this one is supposed to be shaders. Shaders. That explains what's going on in there. That actually explains everything. Okay, so do we still have this stuff shading all over the place? Is a sampler not full? Oh, okay, I see. I'm sorry. Oh shit, I'm sorry. So it has to be I. And I suppose the unit maybe has to be as well like GLint, not GLUint. GL uniform 1I. When you set it like 1I, do you accept int or something else? You accept ints, so because of that we want to accept ints in here too. Alright, so do we have anything else in here? Okay, so it's still shading all over the place. Has one component, not two. Excuse me. Am I an idiot? So we got a sub, by the way. I need to address it just a second. So Any Uvu Ovo, thank you so much for Twitch Prime subscription. Thank you, and welcome to our epic OpenGL club. That is right. That is right. Thank you. So GL Uniform 2 Tech. I don't really know. I'm not really sure that I'm using 2 in there. I'm pretty sure I don't. So that's kind of ridiculous in my opinion. So if I disable that, is it going to be doing that crazy stuff? Okay, so let me find... so am I rebuilding? Yes, I am rebuilding. So why would it do that? General uniform. So in how many places I do that? Tech uniform. Uniform color. Flash sync. Oh, I think. Oh, I see. I think I know what's going on. I have to rebind the program. Yes, I completely forgot to do that. Right, so it's OpenGL letting me know about itself. Right, so we have to bind this program, then you'll be able to do that. Then we bind this program for the Flash, and I completely forgot that after that I have to do what? I have to like use the REPL renderer program, right? So that one. So then I have to clean everything, then only then synchronize the uniforms, and yeah, I completely forgot that I have to do it like that. Okay, so at least it is not shedding all over the place, which is already good. It doesn't have the localized thingy though, right? it doesn't have a localized thingy though yet, which is fine. Ripple renderer, and I'm just trying to render all these things. Okay, so we're getting there. I think we're getting there. So this is a ripple. Maybe this is because I disabled the synchronization of the textures. No, I didn't actually. The synchronization of the textures is fine. So there's something wrong. Something definitely wrong. Is that because I'm using... Okay, so here I can use 0. Right, I can try to use 0. And that should give me something. So what if I use object that is actually smaller? Right, because I want to see something, right? I want to see some effects, but I don't see any effects, which is sad. So we're using this thing, right? We're using this thing. Oh, also, I probably have to also rebind the VAO, the current VAO. Okay. So, yeah, that's probably what we have to do. GL bind vertex. GL bind vertex array. Vertex array. This one is going to be VAO. That's probably what I have to do, of course. I forgot to do a lot of things actually. So, and in here, I'll have to bind the ripple renderer one. Okay, so will that produce anything? I wonder. Okay, so at least we don't see anything anymore. That's nice. That's super nice. But if I just keep it like that, Okay, so I think I completely broke the entire stuff. Oh boy, so I don't really know why it doesn't work. So if I don't bind any VAOs, it is working fine, probably because it's using the VAO that is bind by the second initialization, right? So if I dorinit, we bind that one, so that's the one that is used for whatever reason, which is not what we want. Which is not entirely what we want. So use that program. So if I do it like that. Okay, so it is using the wrong one. It is always using the wrong one. But if I always bind that one, is it gonna work? No, it doesn't work. Interesting. Interesting. So VAO, why would it be like that? Rinit. Do I also have to bind VBO then? I probably have to also bind VBO. Let me take a look. VBO. So because I'm not an OpenGL developer, so sometimes I may not know some like crucial things, so I really apologize for that. Okay, so I never bind that, but I always bind this thing. So hopefully that is... Yeah, okay, so that makes sense. That makes a lot of sense. Thank you. That is very cool. All right, I think I'm getting into something. GL bind buffer. All right. That's very cool. So we might be getting somewhere. Ripple renderer. Oh boy. Hopefully. Okay. Still doesn't do much. still doesn't do. Though I can try to, in the ripple fragment thingy, just always set the color to something like very, very red, right? So we can instantly see that the shader is working at least, right? Because that's what we want to see. We want to see the shader working. At least for now. Can we see anything? Okay, we can't see anything. So that means like it doesn't really draw at all. Doesn't really draw at all. So I would expect it to have like object size, but maybe not. Okay, I see what's going on. I caught it. Copy paste code actually ruined everything. Okay. There we go. Mother flipper. Here is the red in the post-processing. Yes, that is very, very cool. So this is an additional quad in the post-processing, which is like sets us to the success. This entire thing sets us to the huge success. My God. Okay, so now we can have this like thing that is bigger. Right, and now if I go into this fragment shader and I'm start using the texture that we're supposed to be using, we're gonna see a very strange result. We're supposed to be seeing a very strange result because the current texture that we're using is the texture into which we're rendering the whole scene. If everything is set up correctly in that red quad, we should be seeing the whole scene squashed and stretched to fit into that quad. If we did everything correctly, we should see that, right? You see what I mean? Right, let's take a look. It is not correct, but it is something. It is using texture. It is definitely using the texture, but it's using the wrong texture. It is not using the texture of the scene, it is using the texture of a single object. So, at least we know where is the bug, right? So you see, because this is the texture of the object, but there is no effect, rainbowish effect on the object. So it's the only thing that doesn't have the rainbowish effect. So yeah, let me see how we can fix that. So basically I have to set the proper texture. Oh yeah, so essentially I set the texture unit to 0, which is the wrong texture, so I have to set it to 1. All right, so now you can see that. Do you see the whole scene squashed to fit into that thingy? That's what I was talking about. Right, so that's basically what's going on. So in the post-processing, we do have the whole scene. Right, that's actually pretty funny. So, yeah, that's actually really cool. So we rendered the scene into the texture and then we're using that texture. Okay, cool. So let me see what we can do about that. So I can now even apply the ripple effect. Right, so I'm actually like putting it upside down. I think I need to like put it like this so it doesn't go upside down. Right, so it's actually correct now, as you can see. So it is correct, but it's mirroring itself, essentially. Now, what I want to do, I want to just go ahead and apply the ripple effect. Right, the ripple effect in the post-processing in that localized space. Right, so as you can see, yeah, this is basically what we have right now. We have a ripple effect in that localized space. But this is the problem, right? We're using the whole texture. We're not supposed to be using the whole texture in that specific place. We're supposed to be finding the subtexture. We're supposed to be finding that the subtexture for this thing. All right. And that is something that probably has to be done in where? In the Vertex Shader, right? So the Vertex Shader should give us the correct sort of like coordinates and whatnot. That is very interesting. All right. So that's actually very, very cool. Let me go to the render config. What I want to do, I want to reduce the amount of objects. So let's actually say that we're going to have 3 of them. Right, because I want to be able to see the scene after post-processing, right? So yeah, that's what we have. The scene after post-processing. It's actually very cool. I'm actually learning a lot. I've never done this kind of stuff before, but yeah. It's so cool. Anyway, so maybe I'm gonna actually keep this thing in here while I'm, you know, doing stuff. Go back in here. All right, so so what I wanted to do, I wanted to go to the main vert, and I didn't think I want to mess with the main vert. I didn't think so. Right, so we probably need to create something like a ripple vert. Right, so I'm gonna copy paste this thing into ripple vert, and it's gonna be just a copy for now. But then I can do the following thing: main vert, ripple vert, and another one, ripple vert. So let me close that and let me restart this entire thing. Hopefully that will work properly. And now I'm gonna go into the other thing. So I want to check if the hot reloading actually works. Does it still work? So if I do something like this, there we go. So it's working. So I managed to disable the ripple effect and I enabled it back. Right, everything should be okay. So, and in a ripple vert, essentially, we have the vert position, vert, like ver UV. Ooh, this one is interesting. Okay. We set ver UV like this, right? So that means we probably want to do that on CPU. We probably want to set the UV coordinates for this quad on the CPU. I think that's what we want to do. Okay, so let me find quad CR. Right. And when we set in the quad, okay, so here we're just like literally hard coding the UV coordinates. That's literally what we do. We're hard coding the UV coordinates. Maybe this is not something that we want to do, right? That's for sure. That's for sure, for sure. So we'll have to do some other stuff. Okay, so I kind of want to like create the second function that computes the UV coordinates slightly differently. So here we set the UV coordinates like to 0, 1 manually, but now we need to be able to set them based on the current resolution, plus. But we kind of know the current resolution in the Vertex Shader, right? So we can do that. Yeah, we do have a resolution, so that should be fine. So UV kind of becomes useless if you think about that. Well, I mean, it's not that useless. You kind of know how to offset things. All right, if that makes any sense. You kind of know how to offset things, but maybe not. Anyway, so we have the position. And then we are mapping that thing to the screen. We're mapping that thing to the screen. Right. So, but the screen coordinates are actually very interesting. The screen coordinates are very, very interesting. Right, so this one is gonna be half of the width, right? So this is minus half of the width. This is half of the height, and this is minus half of the height, right? Okay, cool. And right, so first thing I want to do, I want to kind of map it from 0 to this and this, from 0 to this and this. And how can I do that? I suppose I can add half of the width and half of the height, right? So I can always add it. So if I have some sort of a position, I just add half of the resolution, right? So and that way I now have this thing and this thing. So after that, I can basically divide it by resolution, right? So because that point, to get sort of like UV coordinates for that specific point, what I have to do is just like divide it by width and divide it by height, which creates a really strange situation, right? So I divide it by resolution like this, and I divide this by resolution like this, and this is sort of like becomes like that. Right. And essentially what I have to do, I just have to take my original point and divide it by 2 resolutions, right? No, I'm an idiot. By resolution and add half, right? And add half. And that way, okay, so that makes sense, I suppose. Or does it? Does it make sense? Does it make sense? Probably does make sense. So, okay, so where are my things? So here they are. So now I'm going to be changing the UV coordinates to fit that. So here I'm just passing UV coordinates, but it doesn't matter. So what I need to do in here is just to take my ver position, right? Ver position divided by resolution, and add half, right? And I did it. I have a localized warp effect. Look at that. Isn't that cool? I have a localized square. This is what I was talking about. Yeah, there is a single localized square. But unfortunately, it is too obvious that it is a square. Right, this is what I was trying to achieve the whole time. This is so cool. It would be kind of cool if we could, I don't know, like make this warp effect to not reach the edges, if that makes any sense. Can you not make it reach the edges so it's not obvious that it is a square, because it's too fucking obvious. All right, so we can go to the repo, right? So I didn't like I didn't even expect to actually manage to do that on the stream. This is so cool. I really like that. Okay, so let me go to the repo frag, and in here what we can do. So we're sort of like using this as a radius, all right? But maybe we can for now put like a hack, and if this thing doesn't fit a certain condition, just like don't use anything. Oh boy. All right. So I need to probably take a look at this stuff. So I suppose this thing keeps rippling more and more. And the radius, so the bigger the radius, the closer I want this thing to be to 0. That's what I want to have. Right. So if we had some sort of like a big radius, so I suppose radius in here is going to be from 0 to 1. Right, and I can do something like C length and basically divide it by half, right, divided by half. And then I can probably mix between this original value, right, this original value, and 0 based on that. So sort of like smooth it out towards the edges, like yeah. I'm not sure if it's gonna work. It's just like I'm pulling out of my ass, but maybe it will kind of smooth out the edges. You still kind of see the edges. So if I make 25, nah, I'll need to think how to do that. I'll need to think how to, yeah, how to make it like more rounded. Unfortunately, I'm streaming for like for 2 hours already, right? So I'm not thinking straight. So I'm gonna leave it as a homework for the viewers. How would you solve this problem? How would you make the edges of that square not visible? Or maybe you would go with a completely different approach. Maybe you're not gonna go with like a post-processing quad. Maybe you're gonna do that entirely in a fragment shader or something like that. But the goal is to have arbitrary amount of this ripple effects, if you know what I mean. Right. So I could probably go on more, but again, when I'm streaming for more than 2 hours, like my brain, you know, is starting to shut down, so I cannot think properly. So yeah, I guess I'm gonna call it a day. That's it for today. Thanks everyone who's watching right now. I really appreciate it. I'm probably gonna, I don't know if I want to upload the source code somewhere, right? Because it's basically like a scratch code. Right, I'm not sure if it's going to be useful for anyone. I suppose the most useful thing is this article, which actually like gives you the description of this, you know, ripple effect. So, and I recommend to check it out. So if you're watching on Twitch, I'm gonna post it in the chat, right? So here it is. And if you're watching on YouTube, I'm gonna post it in the description. So let's actually, you know, put like a huge quad on the entire screen just to get the, you know, the final application working for now. So let me see, where is the stuff? So this is the object size, but instead of object size, I'm gonna just set maybe width and height, and maybe half of those things, right? So this is gonna be half of those things. So let's restart the whole thing. It has to be just a single one, and yeah, that's what we managed to do today, right? So we explored the ripple effect. That's very cool. All right. Does anyone have any questions, maybe? Does anyone have any questions? So let me change something here. Target, where is my target? Target X. So somewhere, yeah, follow. Let's actually remove this thing from here. Right. Does anyone have any questions? People. Does anyone have any questions? Do you have a repo? A repo for what? I do have a repo for Opengl Template that I've been using, but I'm not sure if I'm going to make it a part of the Opengl repo. I suppose I can upload the code of this thing after the stream. So I recommend to check out my VODs channel, right? So where I upload the recordings of the stream. So, and the repo is going to be in the description. Did you try to render the square as a circle, aka just discard any pixels far from the center of the square? I think it will make it super obvious that it's a circle, right? So you would see the edges of the circle. What I want to do, I want the edges of the ripple effect to like smoothly fade out without creating any ridges or like any visible ridges. So that's what I'm trying to achieve. I could try to do that, but I'm already tired, right? So, so I can try to think about that tomorrow already. So maybe there are some tricks to do that. Maybe some cool tricks. All right, I guess that's it for the day. Thanks everyone who is watching right now. I hope this session was entertaining and interesting, right? So because like I think I learned a lot. Hope you did too. And I see you all on the next session. I love you all. Mwah.